Your brand new Ford is rolling off the assembly line with ticking time bombs pre-programmed right into the factory software, and the manufacturer is counting on you to never question them. As a technician who has spent decades with his hands inside these exact engines, dropping oil pans and replacing prematurely warped components, I see the wreckage these default options cause every single day. Ford builds an incredible machine, but their engineering priorities are dictated by corporate compliance, EPA fleet averages, and the marketing department, not the long-term survival of your powertrain past the warranty window. You are operating under the delusion that if the factory said it that way, it must be optimal for the truck. It isn't. It is optimal for Ford's regulatory balance sheet. Today, I am exposing 5 factory settings and features that are quietly destroying your vehicle from the inside out without you ever knowing. Setting number 3 has caused more catastrophic engine teardowns on my lift than almost any mechanical part failure in the last decade. And setting number 1 is so utterly deceptive that most owners actually think it is beneficial to the vehicle, when in reality, it is doing the exact opposite and shaving years off your engine's lifespan. Let's get into it. Setting number 5 is the Factory Intelligent Oil Life Monitor System, coupled with their recommended 10,000-mile drain intervals. Ford markets this as a high-tech, cost-saving convenience that protects the environment and your wallet. Here is how it actually works. The onboard computer uses an algorithm based on engine revolutions, operating temperatures, and driving habits to calculate when your oil is spent. It doesn't actually sample the oil, it guesses. Under normal driving conditions, that dashboard light won't trip until you hit nearly 10,000 miles. But here is what Ford doesn't tell you about modern EcoBoost engines. These are highly sophisticated, direct-injected, turbocharged power plants. Direct injection inherently causes fuel dilution, meaning microscopic amounts of raw gasoline bypass the piston rings and mix directly into your crankcase oil. By the time that oil hits 6,000 miles, the viscosity has broken down significantly, dropping a 5W30 oil down to the thickness of a 20 weight or lower. Simultaneously, the twin turbochargers subject that thin oil to extreme thermal stress, spinning at over 200,000 RPM and generating searing heat. When you push that oil to 10,000 miles, you aren't lubricating your engine. You are circulating a heavily sheared, fuel-saturated slurry contaminated with abrasive carbon soot. This invisible slurry strips the protective film off your timing chain pins, stretching the chain until your cam timing throws a code. Worse, it begins grinding your main and rod bearings down to dust. I have pulled oil samples at 9,000 miles that looked like black water and showed critical levels of copper and lead wear metals. The solution is simple. Ignore the dashboard monitor entirely. Change your oil every 5,000 miles or 6 months using a high-quality full synthetic and an OEM filter. Setting number 4 is one that Ford markets as a premium convenience feature, but under everyday driving conditions. It is creating the exact environment that destroys your automatic transmission, the factory eco mode, and its aggressive, low RPM shift mapping. When you select this setting or leave the vehicle to manage its own economy thresholds, the transmission control module is programmed to upshift as early as humanly possible, keeping the engine operating between W200 and W500 RPM to squeak out an extra fraction of a mile per gallon for the EPA. What actually happens inside the drivetrain is severe mechanical stress, known as engine lugging. When you try to accelerate gently while the computer forces the transmission to stay in 8th, 9th, or 10th gear at low engine speeds, you create massive cylinder pressures. This places an immense torsional load directly onto the torque converter clutch and the internal planetary gear sets. Instead of letting the engine breathe in its natural power band, the transmission forces the torque converter to constantly slip its clutch to damp out the heavy vibrations. This continuous slipping generates localized temperatures inside the transmission fluid exceeding 240 degrees Fahrenheit. At that temperature, automatic transmission fluid oxidizes rapidly, losing its frictional properties and turning into a varnish that varnishes the internal valve body passages. You won't feel the damage initially, but cumulatively, you are frying the friction plates, and setting yourself up for hard shifts, shuddering, and complete torque converter failure well before 100,000 miles. The fix requires zero tools. Stop chasing fractions of a MPG in eco mode. Drive the vehicle in normal mode, or better yet, use Tau Haul or sport mode when navigating hilly terrain, or carrying cargo to keep the engine up in its power band and reduce unnecessary, high-load transmission shifting. Those first two settings are bad enough, but they are just the warm-up for the real powertrain killers built right into your dashboard menu. As we climb higher up this countdown, the engineering compromises become significantly more hazardous to your vehicle's long-term survival. Setting number 3 is the factory auto start-stop feature, a system that has caused more catastrophic engine teardowns on my lift than almost any mechanical part failure in the last decade. Ford installs this feature to shut down the engine every single time the vehicle comes to a complete stop, whether you are stuck in a gridlocked commute or just waiting for a traffic light to change. The manufacturer markets this as an eco-friendly advancement designed to eliminate idle emissions and save you money at the pump. What they don't tell you is that your engine pays the ultimate price for those fractional fuel savings. To understand why this setting is so destructive, you have to look at the fluid dynamics inside your engine's bearings. When your engine is running, the oil pump forces pressurized oil into the tiny clearances between the crankshaft and the rod bearings, creating a microscopic cushion known as hydrodynamic lubrication. Your crankshaft literally floats on a pressurized film of oil, preventing metal from metal contact. The moment the engine shuts off, that oil pressure drops to absolute zero. The heavy crankshaft settles down, pushing the remaining oil out of the way, resulting in direct metal-on-metal contact between the polished steel journals and the soft bearing linings every single time that engine restarts. Those components grind against each other for a fraction of a second before the oil pump can repressurize the passages and lift the crankshaft back up. Under normal operational standards before this feature existed, a vehicle engine would experience roughly 50,000 start cycles over its entire operational lifespan. With auto start-stop left active, that number explodes to over 500,000 start cycles in the exact same time frame. You are subjecting your engine's critical internal wear surfaces to 10 times the amount of dry start friction they were ever designed to handle. The damage is completely invisible, accumulating micrometer by micrometer with every single traffic light. I have personally inspected rod bearings from EcoBoost engines with less than 60,000 miles where the protective overlay was completely worn away, exposing the bare copper underneath. This metal-on-metal friction also places an immense structural load on your starter motor and your battery, leading to premature electrical failures that cost hundreds of dollars to fix. The solution here doesn't cost a dime. Make it a muscle memory habit to press the auto start-stop disable button on your dash the moment you start the vehicle. If you want a permanent fix, you can install an inexpensive plug-and-play inline bypass module behind the switch that remembers your preference and keeps the feature turned off for good. Setting number 2 is a feature that Ford markets as a high-tech safety mechanism, but under certain conditions. It is creating the exact environment that destroys your brake system, kills your fuel economy, and warps your rotors, the factory active grille shutters, paired with the default overly aggressive traction control brake vectoring software. Ford utilizes electronic shutters behind the front grille that automatically close at highway speeds to reduce aerodynamic drag and help the engine warm up faster. At the same time, the stability control system uses the vehicle's actual service brakes to subtly pinch individual wheels during cornering to make the vehicle handle more athletically. Here is the mechanical reality that catches owners off guard. When those grille shutters close to optimize aerodynamics, they severely restrict the volume of ambient airflow entering the engine bay and passing over the front brake assemblies. Under normal highway cruising, this isn't an issue. However, if you are driving through mountainous terrain, towing a trailer, or driving enthusiastically down a winding road, your vehicle's computer is simultaneously pulsing the front brakes via the stability control system to stabilize the chassis while keeping the grille shutters closed for fuel efficiency metrics. because the air inside the wheel wells is stagnant, and T, wrapped by the closed shutters and aerodynamic underbody panels. The heat generated by the service brakes has absolutely nowhere to go. Brake rotor temperatures can rapidly skyrocket past 600 degrees Fahrenheit during completely routine driving maneuvers. When steel rotors reach these extreme temperatures without adequate cooling airflow, the microscopic structure of the cast iron changes. The metal begins to expand unevenly, leading to severe thermal distortion, commonly known as warped rotors. Worst yet, this extreme trapped heat cooks the rubber dust boots on your brake calipers, drying them out until they crack and allow road grit to enter the caliper piston bores. Once that grit gets inside, the caliper pistons begin to stick, causing the brakes to drag constantly against the rotors. This invisible dragging robs you of fuel efficiency, creates a rhythmic steering wheel vibration, and can destroy a brand new set of pads and rotors in fewer than 15,000 miles. The solution to this hidden heat trap requires a change in how you manage your vehicle's drive profiles. When you are operating in heavy stop-and-go traffic, driving through hills, or hauling any kind of weight, manually shift the vehicle into TOW, hot haul, or sport mode. These factory modes override the aggressive aerodynamic mapping, forcing the active grille shutters to remain wide open to dump heat, while adjusting the stability control thresholds to minimize unnecessary heat-generating brake intervention. We have covered the maintenance traps, the low RPM stresses, the dry start friction of the restart systems, and the hidden thermal traps behind your grille. But all of those pale in comparison to the final item on our countdown. This last setting is the absolute pinnacle of manufacturing deception, because it actively tricks you into believing your vehicle is operating in perfect health, while it silently suffocates. Setting number 1 is the factory buffered dashboard gauge cluster calibration, specifically the engine coolant temperature and oil pressure displays. If you look at your dashboard right now, you see beautiful crisp gauges with needles that rise safely right to the middle of the sweep and stay there, rock solid, no matter how hard you push the vehicle. Ford prints numbers and gradients on these screens to make you feel like you are looking at precision diagnostic equipment. It gives you a profound sense of security, leading you to believe that if your truck were running hot or losing lubrication quality, that needle would move and warn you well before damage occurred. That sense of security is an absolute illusion engineered by corporate lawyers to prevent warranty claims. Modern Ford dashboard gauges are not actual, real-time analog indicators. They are what we in the industry call dumb indicators, driven by software buffers. The computer takes the raw data from the engine sensors and deliberately filters it before displaying it to you. For instance, your coolant temperature gauge is programmed to rise to the exact center of the dial when the engine reaches roughly 185 degrees Fahrenheit. Once it hits that middle marker, the needle is electronically locked in place by the software. It will not budge a single millimeter whether the engine is running at a perfectly happy 195 degrees, a stress 215 degrees, or a dangerous 230 degrees. The manufacturer does this because real engines experience natural, constant fluctuations in temperature and pressure, depending on load, air conditioning use, and ambient air. If owners saw their needles dancing up and down during a steep hill climb, they would panic and flood dealership service bays with complaints about non-existent problems. So, Ford decided it was better to keep you completely blind to the reality under your hood. The needle is programmed to remain perfectly dead center until the engine hits a catastrophic threshold, typically around 240 to 245 degrees Fahrenheit. Only then does the software release the buffer, causing the needle to instantly shoot into the red zone as the dashboard erupts in warning lights. But by the time that needle moves, the damage is already done. You don't get a warning that your engine is getting hot. You get a post-mortem notification that your engine is already cooked. Operating an EcoBoost engine at 230 degrees for extended periods while pulling a grade causes the aluminum cylinder head to expand at a different rate than the engine block. This thermal stress destroys the structural integrity of the multi-layer steel head gasket and permanently warps the deck mating surfaces. The oil pressure gauge operates on the exact same deceptive principle. It is essentially an on-off switch connected to a pressure sensor that triggers at a measly 5 to 7 psi. If your engine has more than 7 pounds of pressure, the gauge jumps right to the middle, signaling perfect health. Even though 7 psi at highway speeds means your engine bearings are actively starving for protection. This systemic blinding of the driver is why so many used Fords suffer catastrophic powertrain failures out of nowhere. The owners swear up and down that the truck never overheated because the gauge never moved, right up until the moment the head gasket blew or a rod shot through the block. The solution to this factory-installed blindfold requires you to take data collection into your own hands. You must stop trusting the factory dashboard needles. If you regularly tow, haul heavy payloads, or simply intend to keep your vehicle past the 150,000-mile mark, you need to invest in a basic aftermarket OBD2 digital monitor that plugs directly into the diagnostic port under your steering column. These devices bypass the factory software buffers and read the raw, unadulterated streaming data directly from the engine control module, showing you the true, exact degrees and pressures down to the single digit. This allows you to see a cooling system struggle long before it reaches a terminal failure threshold, giving you the real-world operational awareness you need to back off the throttle, change your driving mode, or pull over before components melt. When you add up all 5 of these factory configurations, a very clear picture emerges. The default parameters programmed into your vehicle from the showroom floor are not optimized to maximize the longevity of your investment. They are optimized to get the vehicle past its factory warranty expiration date while hitting strict federal compliance metrics, leaving you to hold the bag for the compounding. Invisible mechanical wear that manifests down the road. If you want your Ford to be the incredibly reliable, long-lasting machine it is truly capable of being, you have to actively reject the manufacturer's passive operational guidelines. You cannot rely on their automated oil life calculations. You cannot leave the vehicle permanently trapped in low RPM economy modes. You cannot let the engine relentlessly kill its own oil pressure at every stoplight. You cannot allow your brakes to cook in a stagnant heat trap, and you absolutely cannot trust the smiling lies told by your dashboard gauges. True vehicle ownership means taking control of the mechanical realities under the sheet metal. Take these simple steps today. Turn off the auto start features. Change your fluids on a strict mechanical schedule rather than a digital algorithm, and look at the real data driving your powertrain. Protect your machine. Stop letting the factory settings dictate your repair bills, and hit that subscribe button right now so you never miss the brutal, honest mechanical truths the dealerships try to keep behind